Everybody, class M, I want to give you a kind of overview of how we can find trig functions of various angles. Really kind of whatever works best for you is what you should do. I'm just going to show you a couple of different ways you might think about it. Go ahead and share my screen. So class M, and all we're doing is essentially how to find the trig function, find/evaluate the trig functions of our special angles. So when I say special angles, you should be thinking, oh, any angle that you see on the unit circle. So 30, 45, 60, and any angle whose reference angle is 30 degrees, 45 or 60 degrees. So we can list them all out really quickly. 30 degrees, 150 degrees, 210 degrees, 330 degrees. Those are all the angles with 30 as reference angle. 45 degrees, 135 degrees, 225 degrees, 315 degrees. All I'm really doing is 180 minus my reference angle, 180 plus my reference angle, 360 minus my reference angle. 180 minus 45, 180 plus 45, 360 minus 45. And then 60, 180 minus 60, 180 plus 60, 360 minus 60. And then, of course, the quadrantal angles, 90, 180, 270, 360, 0 degrees, list goes on. Of course, there's also something else I'm trying to think of. There's also radians versions, right? So for radians, 30 degrees is pi over 6, and then 5 pi over 6, and then 7 pi over 6, 11 pi over 6. Those all match up with those. And then pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Those all match up with those. And then pi over 3, 2 pi over 3. I'm just looking for the ones that don't reduce. Those all match up with those. And I guess these two, right? And then we have 0 radians, pi over 2 radians, pi radians, 3 pi over 2 radians, and 2 pi radians. Those will match up with those. Not the most elegant way I've ever written it, but gets the point across. So there's probably like 3 really good ways of remembering how to evaluate the trigonometric function of these functions of these various angles. And I will talk about all of them. The first one is just knowing the unit circle. If you want to memorize the unit circle, that is a valid way of doing it. So you might say you're going to get to a test and be like, okay, unit circle time. So yeah, you can see this, right? So I know that these angles are 0 degrees, 30 degrees, 45 degrees, 60 degrees, 120, 135. Oh, but I forgot 90 up here. 150, 180, 210. Right, really, so really the way this works is 0, add 30, add 15, add 15, add 30, add 30, add 15, add 15, add 30. You're always just adding 30 or 15. So 30, 15, 15, 30. Oops, over here, sorry. 30 again, 15, 15, 30 again. Or in radians. So the radians, I feel like it's easier to match up kind of where they go. So I know that this is pi over 6, and this matches up over here with 5 pi over 6, and this matches up over here with 7 pi over 6, and this matches up over here with 11 pi over 6. All these angles have the same reference angle of 30 degrees or pi over 6. And then same deal up here. 45 is pi over 4 radians, matches up with 3 pi over 4 radians, matches up with. When I'm saying matching up, I'm meaning has the same either vertical coordinate, right? These are at the same height, or horizontal coordinate. These are the same amount left or right of the x-axis. This matches up over here with 7 pi over 4. And lastly, we have 60 degrees, which is pi over 3. Not lastly, that's 2 pi over 3. Down here is 4 pi over 3. Over here is 5 pi over 3. And then finally, I should do the quadrantal angles as well. 0 degrees is 0 radians. 90 degrees is pi over 2 radians. I'm just adding pi over 2 every time. So pi over 2 plus pi over 2 is pi radians. Pi plus pi over 2 is 3. Sorry, this is going to be a little messy. 3 pi over 2 radians. And then 3 pi over 2 plus pi over 2 is 2 pi radians. And then we have the coordinates. So I'll remind everybody that this is a unit circle. Its radius is 1. So all of these radius lengths or radii lengths are 1. So if I go 1 to the right, that's the point 1 comma 0. Over here, it's the point root 3 over 2 comma 1/2. Root 2 over 2 comma root 2 over 2. 1/2 root 3 over 2. 0, 1. Now there's a really nice pattern here that the sine values all increase. 0, 1/2, root 2 over 2, root 3 over 2, 1. And I'm going to talk more about that a little bit later. You can keep filling this in this way, or you can kind of use the symmetry and be like, okay, this matches up over here. The y values are the same. The x values is the negative now. Same deal here. Y value is the same, root 2 over 2. X value is negative, negative root 2 over 2. Y value is the same, root 3 over 2. X value is the negative, negative 1 over 2. Then we go down here and all the y values now become negative as well. So from here down to there, it's negative root 3 over 2, negative 1/2. From there to there, it's negative root 2 over 2, negative root 2 over 2. From there to there, it's negative 1/2, negative root 3 over 2. Finally, moving over to this way, same idea, but now all the x coordinates are positive. So from there to there, it's positive root 3 over 2 for x, negative 1/2 for y. From there to there, it's positive root 2 over 2 for x, negative root 2 over 2 for y. From there to there, it's positive 1/2 for x, negative root 3 over 2 for y. Finally, the quadrantal angles. 1 to the right is 1, 0. 1 up is 0, 1. 1 to the left is negative 1, 0. And 1 down is 0, negative 1. That is a totally valid way of just knowing all this. So, but then you have to know how it works, right? So to use this effectively, I have to then be able to say, okay, if I want to find, for example, I don't know, sine of 240 degrees, I'm just looking at the y coordinate here. So it's equal to the y coordinate of that angle, which is going to be negative root 3 over 2. Or if I want to find tangent of 330 degrees, well, tangent is defined to be y divided by x. So tangent of 330 degrees is going to be negative 1/2 divided by root 3 over 2. You don't have to write all this out, but you have to be able to see this and be, okay, that's going to be negative 1 over root 3, which is negative root 3 over 3. It's a totally fine way of doing it. It's more writing than I care to do. Oh, let me actually say one more thing, because one thing we do need the circle for is, for example, if I wanted to find, say, cosine of 180 degrees, then I would have to use the unit circle. There's no other way to really do it for the quadrantal angles, which are 0, 90, 180, 270, 360, 450, or any multiple of 90. I do need to look here to say, oh, the x coordinate is negative 1. So one way of doing this, which is totally valid, is memorize the unit circle. That's not what I would do, but it is something you can do. Let's continue. So another way of going about this, actually, let's talk about the cool kind of pattern. We'll talk about the pattern as we go along with this. So here's another way of doing this. Let's say I want to find the 6 trig functions of, let's say, 300 degrees. We'll do some radians too. So let's say that's what we're trying to do. So here is my usual go-to reference angle. So 300 degrees is in quadrant 4. 360 degrees minus 300 degrees is 60. The reference angle is 60. And either you can draw the triangle for 60 degrees. So, it would look like this. So the sides are, you can either do 1, root 3, and 2, or if you prefer, you can do 1/2 root 3 over 2 and 2 over 2 equals 1. Either way is fine. You can make whatever choice you like. And then I'm going to observe that this angle, which we just said right? 300 degrees is in quadrant 4. So in quadrant 4, right, we know that we're over here where x is positive greater than 0, and y is negative. So we know that cosine is going to be positive and sine is going to be negative. You could also just memorize that in quadrant 4, cosine is positive and sine and tangent are negative. So looking at my triangle, I can see that sine of 60 degrees is root 3 over 2 over 1, or just root 3 over 2. But that's not what I really wanted. I really wanted sine of 300 degrees. Since I'm in quadrant 4, where sine is negative, it's going to be negative root 3 over 2. Cosine of 300 degrees is going to be positive 1/2. Tangent of 300 degrees is going to be opposite over adjacent. So you can either do as root 3 over 1 or root 3 over 2 over 1/2. I like root 3 over 1 personally. Just say it's root 3, or root 3 over 1 equals root 3. And then I never really think that hard about the 3 reciprocal functions. I just flip these over. So I can see the cosecant of 300. Oh, tangent, I made a mistake. I did make a mistake. I forgot to mention that tangent is going to be negative since our angle is in quadrant 4. Cosecant of 300 degrees is the reciprocal of sine of 300 degrees. So it's going to be negative 2 over root 3, which is negative 2 root 3 over 3. I always recommend writing the negative just out in front of the fraction. That's my preferred way of doing it. And then secant of 300 degrees is the reciprocal of positive 1/2, so it's going to be positive 2. And cotangent of 300 degrees is the reciprocal of negative root 3 over 1, so it's going to be negative 1 over root 3, which we should rationalize as negative root 3 over 3. Be sure to write the correct angles that you're taking: sine, cosine, tangent, cosecant, secant, cotangent of. But that's one way of doing it. Let's do another example just to kind of solidify that, because to be honest, this is the way I would recommend doing it. I'll do it slightly differently. So here's kind of a mixture of the two. Let's say we wanted to find, again, these 6 trig functions of 135 degrees. Let's call it 3 pi over 4 though. I always think of these as being kind of the easiest ones, because I know sine and cosine are essentially going to have the same value, except one of them might be negative, or the one or both of them might be negative. So here's how you might do this instead. Instead of doing what I did, where I'd like to draw the specific triangle, you might just memorize the first quadrant of the unit circle and be like, okay, well, I know that for this angle, the point is 1, 0. And for this next angle, which is 30 degrees, the point is root 3 over 2, 1. For the next point, which is kind of the middle, it's root 2 over 2, root 2 over 2. And then for the next angle, which is 60 degrees, it's 1/2, root 3 over 2. And then finally up here, 0, 1. And the angles are theta equal to 0 degrees, theta equal to 30 degrees. I was going to write pi over 6. Theta equal to 45 degrees, theta equal to 60 degrees, theta equal to 90 degrees. So we're dealing with 3 pi over 4. We know pi over 4 is 45 degrees, so we're dealing with this angle here, but we're in quadrant 2, because 3 pi over 4 isn't pi over 4, it's 3 pi over 4. So here's what I'm going to say. I'm going to say that in quadrant 2, I know that sine of theta is positive, and so is cosecant, but you don't have to write that down. And then we also know that cosine is negative and tangent negative. I never write down the reciprocals because it's kind of just something we know. Oh yeah, if these 3 are positive, or if these 3 are, this is positive, and these 2 are negative, then the reciprocal of sine is also positive. The reciprocal of cosine and tangent are both also negative. So I'm going to start writing this down and say, okay, sine of 3 pi over 4 is going to be positive. Cosine of 3 pi over 4 is going to be negative. Tangent of 3 pi over 4 is going to be negative. And then the reciprocals, cosecant, don't forget the little c there, the 3 pi over 4 is going to be positive as well. Secant of 3 pi over 4 also negative. Cotangent of 3 pi over 4, also negative. So now sine of pi over 4 would be root 2 over 2. So sine of 3 pi over 4 is going to be positive root 2 over 2. Cosine of pi over 4 would be root 2 over 2. So cosine of 3 pi over 4 is going to be negative root 2 over 2. I suppose I could have written the other angles here. This is 0 radians. This is pi over 6 radians. Pi over 4 radians. Pi over 3 radians. Pi over 2 radians. Tangent. So there's a nice thing about tangent when you write it this way. Tangent is just the y coordinate divided by the, that should be a 1/2. Sorry about that. I missed the 1/2 there. Tangent should be the y coordinate divided by the x coordinate. In this case, it's root 2 over 2 divided by root 2 over 2. When you divide something by itself, you just get 1. So I'm looking at this divided by this is going to give me a -1. And the reason one of these right like this is because tangent is just the sine value divided by the cosine value, which is just in this case -1. Over here, we just get the reciprocals. Reciprocal of root 2 over 2 is 2 over root 2, which is just root 2. Reciprocal of root 2 over 2 is just root 2, but it's negative root 2. Reciprocal of -1 is -1. Okay. So this is kind of one of the two ways I think about it. I think about what quadrant we are in to determine what positive or negative sign each trig function has. And then I just think about what reference angle I'm using. And I either draw the angles in the first quadrant, or I, like in the previous example, I like to use the appropriate triangle to help me figure out what's going on. Either way is fine. Let me talk about one more way of memorizing this, because maybe you don't want to do either thing. And again, you have lots of options. It doesn't really matter which way you do it as long as you can do it correctly. So here's one more nice pattern. Again, this is for the first quadrant. I'm going to draw it this way, and I'm going to draw it another way as well. So here's my first quadrant of my unit circle. And let's draw the points again. I know it's kind of tedious. So we'll do the points first. I'm going to split the difference and then kind of cut that way. Maybe this is a little bit shallow. So here's my point, 1, 0. My angle is 0. 0 degrees, 0 radians. This one here is my root 3 over 2, 1/2. 1/2, not just 1. And my angle there is 30 degrees or pi over 6 radians. This one here is kind of the midway point I like to think of in the first quadrant. It's where sine and cosine happen to be the same. It's literally along the line y equals x, right? And the line y equals x does make a 45-degree angle with the origin, or with the x-axis, I should say, really. Don't worry, we're getting there, I promise. It's just taking a minute. And my angle here is 60 degrees or pi over 3. And finally, up here at the point 0, 1, the angle is, of course, 90 degrees or pi over 2 radians. Okay, but here's what I want you to see, because I think it's useful. As your angle gets larger, as we go from here to here to here to here to here, you're moving up. So all the y values, 0, 1/2, root 2 over 2, root 3 over 2, 1, get larger. And similarly, or not coincidentally, all the x values, 1, root 3 over 2, root 2 over 2, 1/2, 0, they all get smaller. That is always true in the first quadrant. As the angle gets larger from 0 to 90 degrees or 0 to pi over 2 radians, the sine values get larger, the cosine values get smaller. There's a really, really, really convenient way of remembering them. So let me show you what I mean. We're going to make a chart for sine, cosine, and tangent, because why not? So our angle is going to be 0 degrees equal to 0 radians, 30 degrees equal to pi over 6 radians. We're just increasing the angle. 60 degrees equal to pi over 3 radians. 90 degrees equal to pi over 2 radians. Now check this out. We're going to do sine of our angle, cosine of our angle, and then tangent of our angle. Just as a quick reminder, right, in the unit circle, it is literally, I know I said this in class a couple times already, but I'm saying it again, it is literally the case that if your radius is 1, this is your angle theta, this right triangle has some x and y coordinate on the circle. Cosine of theta is adjacent over hypotenuse, which is just x. So that x coordinate really is cosine of the angle. Sine of theta is opposite over hypotenuse, which is just the y coordinate. Y divided by 1 is just y. And then tangent of theta, which is opposite over adjacent, well, y is equal to sine of theta. And cosine is x is equal to cosine theta. So you can actually find tangent of theta by just dividing the sine value by the cosine value, which is what we're going to do here. Okay, so for 0 radians or 0 degrees, sine is equal to 0. Now I'm going to write it in kind of a dumb way. I'm going to write it as the square root of 0 divided by 2. And you'll see why in a minute. Square root of 0 is 0. 0 divided by not 0 is 0. 0 divided 2 goes into 0 0 times. So this is equal to 0 divided by 2, which is just 0. Okay. We'll fill out the sine one first, then we'll come back and get the cosines. So sine of 30 degrees is 1/2. I'm also going to write this in kind of a dumb way. It's equal to the square root of 1 over 2. Square root of 1 is just 1, so this is equal to 1/2. Sine of 45 degrees is root 2 over 2. Sine of 60 degrees is root 3 over 2. Sine of 90 degrees is 1, which I'm going to write as the square root of 4 over 2. I know, seems silly, but square root of 4 is 2, and 2 divided by 2 is 1. So look, there's this really, really lovely pattern that in the first quadrant, if we look at the special angles, if we just go from 1 to the next, you get the square root of 0, 1, 2, 3, or 4, all divided by 2. So first special angle is 0 degrees, you can square root of 0 over 2. Second special angle is 30 degrees, you can square root of 1 over 2. Third special angle is 45 degrees, you can square root of 2 over 2. Fourth special angle is 60 degrees, you can square root of 3 over 2. And the last special angle, ending the first quadrant, it's not technically in the first quadrant, is 90 degrees, you get the square root of 4 over 2. And then the cosine pattern is just the reverse. Cosine starts at the square root of 4 over 2, which is equal to 1. And then cosine of 30 degrees is square root of 3 over 2. Cosine of 45 degrees is square root of 2 over 2. Cosine of 60 degrees is square root of 1 over 2, which is just 1 over 2. Cosine of 90 degrees is the square root of 0 over 2, which is 0 over 2, which is 0. You don't have to do it this way, but it is kind of a cool way of remembering, oh yeah, sine of our special angles is just square root of 0 through 4 over 2. And cosine of our special angles is just square root of 4 through 0 over 2. It's weird, but it works. And then finally, tangent is the quotient of this divided by this. So tangent of 0 degrees is 0 divided by 1, which is 0. Tangent of 30 degrees is 1/2 divided by root 3 over 2. The 2's cancel. You get 1 over root 3, which we rationalize as root 3 over 3. Tangent of 45 degrees, root 2 over 2 divided by root 2 over 2. I really don't think you need to write that out, because when you divide anything by itself, you just get 1. I should also... Finally, tangent of 60 degrees is root 3 over 2 divided by 1/2. Again, the denominators cancel and you get root 3 over 1, which is root 3. And finally, tangent of 90 degrees is 1 divided by 0, which is undefined. It does happen. So there's another way of knowing what sine, cosine, and tangent, and also the reciprocals are equal to in the first quadrant. So I'm really, really not a fan of memorizing the entire unit circle. I think it's worth just memorizing what's going on in maybe the first quadrant of the unit circle, either this way, or by memorizing the triangles, right? You can also, you can say you've got your 45, 45, 90 triangle and write it like this, root 2 over 2, root 2 over 2, 1, or whichever way you prefer. It's also perfectly good to write it as like 1, 1, root 2. Right, that's also a valid way of writing your 45, 45, 90 triangle. Similarly, your 30, 60, 90. Right, I know I already wrote one of them, but you can write it like this. Write it as, remember, opposite 30 goes the smallest side. So it can be 1, opposite 60 is root 3, opposite 90 is 2. Or if you like the smaller version of this, sorry, I'm running out of room here, apologize. You can do a 1/2 opposite 30, a root 3 over 2 opposite of 60, and a 1 as your hypotenuse. Let me zoom in a little bit so you can see that a little bit better. So there are your special triangles, right? 45, 45, 90. These two legs should always be the same. Hypotenuse is bigger. 30, 60, 90, or 60, 30, 90. Opposite 30 is the smallest. Opposite 90 is the biggest. Opposite 60 is the medium. Opposite 30 is the smallest. Opposite 90 is the biggest. Opposite 60 is the medium. Just for reference, the square root of 3 is approximately 1.73. So the square root of 3 over 2 is approximately 0.86. So you're having trouble remembering which one's bigger. If you remember these decimals, you're like, oh yeah, 1 is smaller than 1.73 and 1.73 is smaller than 2. Or 1/2, which is 0.5, is smaller than 0.86, which is smaller than 1. So there are ways to remember the things. So summing this up, use whatever method you like to evaluate the trig functions of an angle in a special angle in any quadrant. And this will be something that you're kind of expected to do without any reference. So for example, I might ask you on the test on Thursday to find the 6 trig functions of, let's go quadrant 3, let's say 240 degrees. And you can do it whatever way you like. You could certainly, if you want, draw the unit circle and think about, okay, well, 240 degrees is about like that. Dropping your perpendicular always to the x-axis, that's looking like a 60-degree reference angle right there. And you could either label this point, for 60 degrees, the y value is the larger one. So this is looking like x is negative 1/2, y is negative root 3 over 2. So you can just straight up say, okay, sine of 240 degrees is negative root 3 over 2. Cosine of 240 degrees is negative 1/2. Tangent of 240 degrees is negative root 3 over 2 divided by negative 1/2 is positive root 3. And then the reciprocals. Cosecant of 240 is negative 2 over root 3, which rationalizes as negative 2 root 3 over 3. Secant of 240 is negative 2. Cotangent of 240 degrees is positive 1 over root 3, which rationalizes as root 3 over 3. Or maybe you don't want to do it that way at all. Maybe you want to say, hey, instead, you want to draw the reference angle, the triangle, the nice triangle. You go, okay, well, my triangle is like this. And maybe you don't want to draw it where like the sides are negative 1/2 and negative root 3 over 2. You want to draw it where the sides are like small side is 1, medium side is root 3, big side is 2. We know that we are in quadrant 3, and if you want to think about the all students take calculus acronym, that's telling us that tangent is the positive trig function and sine and cosine are things. When we do the all students take calculus thing, which is a nice mnemonic device to use, we were talking about the 3 primary trig functions, sine, cosine, and tangent, where we recognize that the reciprocals automatically have the same positive or negative sign. So knowing that tangent is positive means that cotangent is also positive, and then the other 2 functions, sine and cosine, and their reciprocals, cosecant and secant, are negative. So you can do it that way and say, okay, well, I know that sine of 240 degrees, if I look at sine of 60, opposite of hypotenuse is going to be root 3 over 2. Cosine of 240 is going to be adjacent of hypotenuse 1 over 2. Tangent of 240 is going to be opposite over adjacent, which is root 3. And then reciprocals. You might be thinking to yourself, James, you've forgotten something. Don't worry, I'm going to get it. And then secant of 240 would be 2. Sorry, I know my brain's getting a little messy. And cotangent of 240 would be 1 over root 3, which is root 3 over 3. And then I go back and say, oh, wait, tangent's positive. Cotangent is positive. You don't actually have to write the positive signs, but I like to emphasize this here. And then The rest are negative. So it's a negative 1/2, a negative root 3 over 2, a negative 2 root 3 over 3, and a negative 2. That's another way you can go about it. Be like, just get all the values first, and then after you find all the values, use the quadrant you're in to fix whether things are positive or negative. Okay. So again, you have a lot of options when it comes to how you want to evaluate the trig functions of our special angles. You can memorize the whole unit circle. You can memorize the triangles and where things are positive or negatives in which quadrant. You can also use this thing I just showed you on the previous page, where you have this nice pattern for sine and cosine. There's also this thing people do with like their fingers, where like they're like, you know, sine of like 30 degrees, they count down to the second nice angle, they put their finger down, and then sine of 30 is 1/2, and cosine of 30 is the square root of 3/2. I've never been good at that. It doesn't really work that well for me, but some people, right, it works. So like, so if you count to like, you know, the third special angle, sine of 45 is root 2/2, and cosine of 45 is root 2/2. It works, but it's, I don't know, I don't think it's that great personally. Okay, the last thing I should bring attention to is the quadrantal angles. And I know we did those in class today, but I think it's worth revisiting. So for the quadrantal angles, you will have to use the unit circle there, or memorize them, but it's such as using the unit circle. There really is no other good way of doing it. So for the quadrantal angles, I just think quadrantal is a fun word to say. So quadrantal angles, so again, 90 degrees, which is pi/2, 180 degrees, which is pi, 270 degrees, which is 3 pi/2, 360 degrees, which is 2 pi, 0 degrees, which is 0 radians, or anything that is hyperextended, like 450 degrees, which would be 5 pi/2, or 720 degrees, which would be 4 pi. Any angle that terminates along either the x or the y axis. Right, 90 degrees is straight up, 180 is to the left, 270 is down, 360 is to the right, so on. That's where you kind of have to use the inner circle. So if I have one of these angles, I'm always going to draw, so for quadrantal angles, or for these angles, I like to draw what I call the abbreviated, quote unquote, I know it's terrible, I'm gonna say it anyway, abbreviated corners of the unit circle. Really, you only need to draw the corner that you actually need the angle for, but here's kind of the bigger abbreviated picture. So here's my unit circle, and I'm only caring about these 4 points. Here, my point is 1 to the right, so it's 1, 0, right? It's still a unit circle where the radius is 1. I've gone 1 in the positive y direction. I've gone 1 in the negative x direction. I've gone 1 in the negative y direction. So remember, if you're above the x-axis, y is positive. If you're below the x-axis, y is negative. If you're to the left, x is negative. If you're to the right, x is positive. And then the angles. Here, the angle is 0 degrees or 0 radians. And then if you've made a full revolution, it's 360 degrees, 2 pi radians. These are not the same angles, but they are coterminal. Up here, you have 90 degrees, which is equal to pi/2 radians. Over here, you have 180 degrees, which is equal to pi radians. Down here, you have 270 degrees, which is equal to 3 pi/2 radians. So for example, I could have asked to say, find the 6 trigonometric functions of 3 pi/2. So I would draw my abbreviated corners of the unit circle. I would locate 3 pi/2. I would observe that the x value is 0 and the y value is -1. And I remind myself that sine is the y. Cosine is equal to the x. Tangent is y divided by x. And the rest are just the reciprocals. So here I'm going to say sine of, you should write the angle, right? We don't just want to write sine of theta or no angle at all. I was about to write 270. I really should write, I like to keep it in the units given, so I'm going to write it sine of 3 pi/2. It is okay to change it to degrees. I would just prefer you didn't, but doesn't mean it's not right to do it that way. So you can if you want to, but I think it's more work to change it personally. So sine of 3 pi/2 is the y coordinate, which is -1. cosine of 3 pi over 2 is the x coordinate, which is 0. And tangent of 3 pi over 2, I do think it's okay to write that it's -1 divided by 0, because tangent is always sine divided by cosine, or y divided by x. But -1 divided by 0, I would either cross that out or say this is undefined. And I would make sure you emphasize the undefined nature. Whenever we have something divided by 0, it is undefined. And then we do the reciprocals. So the reciprocal of -1 is -1. Fun fact, when you have two reciprocals of each other, unless they are 0 and undefined, reciprocals should always multiply to +1. So 2 and 1/2 are reciprocals. 2 times 1/2 is 1. 7 and 1/7 are reciprocals. 7 times 1/7 is equal to 1. -1 and 1 divided by -1, which is -1, are reciprocals, because -1 times -1 is +1. Cosine of 3 pi over 2 equals 0. The reciprocal of 0 is 1 divided by 0, which is undefined. So essentially, whenever one of these two things, whenever one of the reciprocal pairs is 0, the other one will be undefined, and vice versa. Whenever one of them is undefined, the reciprocal will be 0. So secant of 3 pi over 2 is going to be undefined. Right, we're going to get a 1 over 0. And finally, cotangent of 3 pi over 2. I do think it's worth thinking about the fact that cotangent of theta is x over y, because it's kind of weird to say like the reciprocal of undefined is 0. It's a little shaky. We should really be like, oh yeah, cotangent is just the 0 divided by -1, and 0 divided by any non-zero number is just 0. So there are your 6 trig functions of a quadrantal of 3 pi over 2. Let's do one more and then we'll call it a day. I know this is mostly just review of what we did today, but I think it's good to see it again, because really the expectation is that you are able to easily evaluate the 6 trig functions, or at least the primary 3, sine, cosine, and tangent, of any one of the angles that show up on the unit circle. Okay, let's do one more. Sure, let's do, again, 6 trig functions. Sure, let's go with a nice 0 degrees. It always feels kind of weird, but 0 degrees. Okay, so I would either draw this somewhere where you can easily see it, or draw it every time. I probably wouldn't want to draw it every time. So I'm not going to do all the work this time. I'm not going to label all 4 of these points. Just be like, okay, well, my angle is 0, which is to the right, and that point there is 1, 0. 1 is the x, 0 is the y, x is the cosine, y is the sine. You don't have to write all that, but if it helps you remember what things are, it's good to do. Okay, so I will admit it can be slightly confusing, because we are in the typical pattern of always doing sine, cosine, tangent. But when you write these as coordinates, cosine comes before sine, so just be a little bit careful there. If you want to write these out of order, that's fine, but just be aware that sine of 0 degrees is going to be not the first thing that comes up, it's the y coordinate. Cosine of 0 degrees is going to be the x coordinate. Tangent of 0 degrees is going to be y divided by x. 0 divided by not 0 is 0. And then the reciprocal. So we know the reciprocal of 0 should be undefined. So cosecant of 0 degrees is going to be, I like to write is undefined. Feeling like you're saying something is equal to undefined is a little bit wrong. It's not wrong enough that I'll mark you off for it, but technically nothing really equals undefinedness. So we just say it is undefined. Small point of, right, it's not a big deal. Secant of 0 degrees, the reciprocal of 1 is 1. And it should be 1, right? Because reciprocals, when you multiply them together, 1 times 1 is 1. They should always multiply to 1. And then finally, cotangent of 0 degrees. Well, the reciprocal of 0, just like the reciprocal of sine was undefined, the reciprocal of tangent is going to be undefined for the same sort of reason, because you're going to get division by 0. Right? This would have been 1 divided by 0. This would have been the reciprocal of that, which is 1 divided by 0. So whenever you have 0 in the denominator, you're getting an undefined expression. When you have 0 in the numerator, that's fine. 0 divided by 5, 0 divided by 1, 0 divided by 7. It's always going to be 0. The only issue, which won't come up here, but I don't know. I won't even say it. 0 divided by not 0 is totally fine, and that's all you're going to see in this context here. 1 divided by 0 or -1 divided by 0, like in the previous one here, that's where you get undefined expressions. Okay, I've said more than enough. It's been, 40 minutes. Did not mean to go quite so long, but I felt like I had a lot to say. So hopefully you find this informative. I will remind you all, if you haven't already watched the video from over the weekend, which I know was long, sorry, they're getting longer. I'm not meaning it longer. I would encourage you to watch it. It's really good to be aware of, or you feel in tune with what's going on with the unit circle. So, and also if you have any questions, you're always welcome to shoot me an email, ask me in class. I'm happy to try to recontextualize things or show it in a different way. I'm trying to give lots of options here. So anyway, I'll see you all tomorrow, or I'll see you today if you're watching the video on Tuesday. Either way, I'll see you Tuesday.